Hello everyone. Now we are going to discuss what is a stack. Before knowing what is a stack, what are the operations that can be performed on a stack and what are the applications of a stack, let us first know what is the basic terminology. What is a data structure? We define data structure as a method of storing data in a computer so that it can be used efficiently in a well organized manner. The data structure mainly deals with how the data is organized in the memory, how we are going to store the data in the memory in an efficient way, and it also deals with how the data can be retrieved and manipulated efficiently. We must also study about the classification of a data structure. A data structure is classified into primitive type of data structure and non-primitive type of data structure. What is a primitive type of data structure? A primitive type of data structure is a kind of data structure that can be manipulated directly by the machine instructions. Nevertheless, to mention, primitive data structures consist of all the or it includes the C data types such as integer, floating point, character, double and pointers. The next classification is the non-primitive data structures. It is a vast classification in data structures. What is a non-primitive data structures? It is the type of data structures that are not or it cannot be manipulated directly by the machine instructions. Non-primitive data structures can be further classified into linear type of data structures and non-linear type of data structures. So what is a linear type of data structures? So the arrangement of data items, when the data items are arranged in a linear or a sequential order such that they are placed one after the other is called as linear data structure. And a non-linear data structure, it is not arranged sequentially, but the data items are arranged such that they represent some specific relationship. That is known as non-linear data structures. Again, the linear data structures are further classified, or the types of linear data structures are arrays, stacks, queues and linked lists, and the non-linear data structures are trees and graphs. So now we will be studying the linear type of data structures, that is the stack. So whenever anyone is going to study about the data structures, the first and the foremost concept that we study is what is a stack. The stack is the basic data structure and the general first data structure what we study. So what is a stack? So a stack is a special type of linear data structure where the elements are inserted from one end and the elements are deleted from the same end. So to understand more clearly, let us consider this example. So this is the simple representation of a stack. In this, the elements can be inserted from one end. Suppose we'll say the elements can be inserted only from this end and it can also be deleted from this end. So the position or the point from where the elements can be deleted or inserted is called the top of the stack. Since we insert the element from one end and we also delete the element from the same end, so the last element which will enter into the stack will be the first element to be deleted from the stack. So this type of data structure, so stack is also referred to as LIFO, which is abbreviated as last in first out type of data structure. So moving on, we will be studying about what are the various operations that can be performed on a stack. So the stack performs three operations: push operation, pop operation and display operation. So let us see what is a push operation. So push operation is nothing but inserting an element into the stack is called as push operation. And We should also keep in mind this condition that only one item can be inserted into the stack at one time. Only one item can be inserted. Like you cannot insert two or more elements at the once into the stack. Only one item can be inserted into the stack. And next is the item should be inserted from the stack. It should be inserted at the top, at the position that is the top of the stack only. We'll see an example. First, let us see, this is an empty stack with the stack size as 4, and always the index will start from 0 to n minus 1 or stack size minus 1. So we are taking a stack size of 4, the index will end at 3, that is 4 minus 1. Next, we want to insert an element, say 30 or whatever of your choice. So the inserting of element will take place at the top. Initially, the top is at the minus 1 position. Next, if you want to insert an element into the stack, you must increment it by 1 plus 1. So the top moves to the 0 position, and there you are going to insert the element 30. Next, you want to insert another element, say 20. Next, the top is incremented by plus 1, and the next element gets inserted, and so on. And now here the elements are full. The stack is full. So is there can we add more elements into the stack? What condition arises? So let us know. So when elements are being inserted, so there is possibility that the stack becomes full. And even though the stack is full, and if you still want to insert the element into the stack, then it results in stack overflow condition. So this completes the push operation. So now let us quickly see how to write a C function to insert an element into the stack. So this is the void push. The name of my function is push, and in that we have to check if top is equal to stack size minus 1. So coming back to this example, why do we require to check stack size? Top is equal to stack size minus 1, because if the top is pointing at the stack size minus 1, that is here the last element, and if you still want to enter the elements into the stack is full, so we print a condition that is stack overflow and we return. In case if this is not happening, and we take an example where the top is at other positions, not at the minus 1, not at the stack size minus 1 position, then we check top is equal to top plus 1. We increment the top, we keep on incrementing the top by plus 1, it moves to 2, plus 1 it moves to 3, and then we insert the item or the element into that position, the top position. So here S represents the stack S. So next operation is the pop operation. So deleting an element from the stack is called as pop operation. Here also we should keep in mind that only one item can be deleted at once, and that the item or the element which we want to delete should be deleted from the top of the stack only. So consider an example. Now we will be considering an example where the stack is full. From there we will be popping or deleting the element. So first it will be pointing, the top is pointing here, so we should remove an element or delete an element from the top only. So we delete 5, then 10 here. So we must keep in mind that as you observe carefully, for the push operation you increment the top, and for pop operation you decrement the top. So here, now we come finally to a stage where the stack is empty. So what happens if you further try to delete elements from an empty stack? What condition arises? So when elements are being deleted, so there is possibility of the stack becoming empty. Even after the stack become empty, if you try to delete an element from the stack, then it results in stack underflow. That is stack overflow, where the stack is full and still you try to insert. This is stack underflow, where the stack is empty and you still try to delete the element or the item. So this completes the pop operation. So let us quickly see what is a C function to delete or to pop an element in the stack. So I give my name of the function as pop, and we check whether top is equal to minus 1. So why do we require to check this condition? Because if top is already here, if top is already if top is already at -1, if top is already at -1, like for example, let us consider if top is already at -1, then you cannot further, the top already points to the east and we cannot further delete. So hence it prints a statement saying stack underflow and we return. If this is not the case, then what we do is the item we are going to pop from the top minus minus. We decrement the top by -1 and we pop the item, we return the item back, means we pop it. Next, the third operation is the display. Basically, display is nothing but the giving output of the stack items, and the items are printed from bottom to top. So we say that stack is a bottom to top approach. In case, let us consider that there is no items. If items are present in the stack, then okay, the elements or the items will be present, will be given output from bottom to top. If there are no items, suppose there are no items in the stack, then an error message will be printed. So the output will be as follows. Consider this example. So here bottom, so 30 will be printed first, then 20, then 10. So now let us quickly see the C function to display and to display the stacked items. So void display, here I declare an int I for the loop and the position, and next we have to check if the stack is empty, because if the stack is empty there will not be any display of the items. Next, if in case it is empty, then we print the error message, else we print the contents of the stack. We put a for loop and we check from I is equal to 0 to I is less than or equal to top, the top till varied point, and we increment and we print the elements. Here S is the stack and S of I is the position, like for F of 0 is the element at 0 position will be printed, for S of 1 is the element at the first element, for the element at the first position will be printed, and so on. So these are the operations performed by the stack. Next, we are seeing the applications of stack. This is the last part of this video. The applications of stacks are, so the first application is conversion of expression. So conversion of expression, will be studying what is an expression, what are the types of expression detailedly in the next part of the video. And so to give a quick glance, expression, there are three types of expression: infix, postfix and prefix. So they require some conversion from infix to postfix, prefix to postfix, and so on. And we'll also be studying which type of expression is more beneficial and efficient. The next second one is evaluation of expressions, like how we evaluate postfix evaluation will be seen further. And third one is recursion. As we all know that recursion is nothing but calling of a function by itself again and again is called recursion. So we can say some we can include some examples such as Tower of Hanoi, etc. in problems like which comes under recursion. These are the problems which come under recursion. And the fourth one is like other applications, such as to find the palindrome sequence and to find whether the given input is valid or not, and so on. So all these applications these are the applications of a stack, and in the next video we'll be seeing what is an expression, what are the types, and how do we convert, and how do we evaluate a postfix expression, and we conclude this stacks chapter. Thank you.